Hi students, this is a video giving you some examples from section 8.5, which is talking about vectors and the resultant forces that are created when you have two vectors acting on an object. For this first example, we have two forces, one that is 50 newtons and the other that is 60 newtons, and they're acting on an object at a right angle. So we'll draw a picture to start this. It is going to look like one vector moving in this direction. We'll call this one the 50 newtons. And then we'll make a 90-degree angle going this way, and we'll say that this vector is 60 newtons. That's just the force that's being applied to each of them. Now, if we have an object that's over here that's being pulled in two different directions simultaneously, the result is going to move this direction. And the way that we determine how far it goes and where it sort of ends up is based on this idea called the parallelogram rule. That if we draw two lines that are parallel to the original vectors, the result is going to end up going across this diagonal. And so the vector that we're trying to find, which would be the result, is this diagonal that's created by drawing a parallelogram. To find the length of that vector, the length or the magnitude, how long that vector is, we use the Pythagorean theorem. We know that this side of a triangle that's created is going to be the same. This is also going to be 50. So to find the length of V, we're going to say that this is the notation that we use. That absolute look kind of like absolute value, but it means the length of a vector. The length of that vector squared, or the length of the hypotenuse squared, is going to be the same as 60 squared plus 50 squared, taking the two sides of the right triangle that's created. Or just the length of the vector, which is what we're trying to find, is the square root of 60 squared plus 50 squared. And then if we plug that into a calculator, hang on, oh, gotta grab my calculator. We should get approximately 78 newtons, rounding. So that's the force that the object is going to move in that direction. The second part of the question is asking us to find the resulting angle that makes, and in this case with the larger force. So we're looking for this angle here that's between the resultant vector and the larger force, which is the 60 newtons. So we want to find that angle. We have a triangle that's drawn with two components of 50 and 60, and based on trigonometry, we can say that the tangent of the angle that we see, the tangent of theta, is the opposite side, which is 50, over the adjacent side, which is 60. So in the calculator, we'll type in that theta is going to be tangent inverse of 50 over 60. And if we plug that into the calculator, we'll get that the angle is, rounding it, approximately 40 degrees. So here's our magnitude or length of the vector. Sorry. And then this is the angle that's created. All right, let's look at a different example. If we're given two angles and we want to find the sum, adding them together is the resultant vector, similar to the example that we just did. So this is asking us to find the result of two angles or two vectors that are acting upon one another. Where does the result end up? And then how long is that vector that's created? And then also what angle does it make with one of the vectors in particular? So for our first example, let's suppose that we're given that vector u has a magnitude. When we have these absolute values, that gives us the magnitude or the length or the strength of a particular vector. That angle, our vector u, is 54 in magnitude, and vector v is 43 in magnitude. And the angle between the two vectors is 150 degrees. So let's draw a picture to represent this. We would have something that looks kind of like this. Let's call this vector v. And then let's call this vector u. And to figure out what the result is, u plus v, it's going to be taking those two forces and figuring out where the result is when they act together. So I draw a parallel line to vector u, and then I draw a parallel line to vector v. And so the result is going to be the diagonal of this parallelogram that's drawn. So the vector that I've drawn in red across is u plus v. That's the vector we're looking for. So there's a triangle that's been created. This side of the triangle is 54. This side of the triangle is 43. We know that this angle here is 150, right? So that means that this angle is 30 degrees. And then this angle also here is 30 degrees because we have a parallelogram. So what I'm looking at is trying to solve a triangle where I have 30 degrees here, I have 43 degrees, or 43 for magnitude here, and I have 54 for magnitude here. And I'm trying to find this value over here, which is the magnitude or the length of the vector, u plus v. And so in this case, I'm going to use the law of cosines. By the law of cosines, the length of the vector, we'll call it u plus v, is going to be one of the sides squared plus the other side squared. Oops. And then I subtract 2 times the two sides multiplied together. Times the cosine of the included angle, so times the cosine of 30 degrees. This is the law of cosines. So let's type that in the calculator. And what we actually want to do is take u plus v, which will be the total magnitude, and we'll take the square root of this whole quantity. So if you want to just type this into the calculator once to get a single calculation before rounding, that's probably easier to do. So plug that into your calculator once. And you should get that the magnitude of the resultant vector is about 27.3. The original directions, I think, said to round to the 10th place. So this is the magnitude. The second part was asking us to find the angle between the resultant vector and the vector u, in this case, the longer vector. So they're asking us to find this angle right here. So this angle here. Now, again, this is not necessarily a right triangle. We don't know that one of the angles is 90 degrees. So we've got to use, in this case, we'll use the law of sines to find that missing side. So I've got 30 degrees, and I've got, oh no, I want to find theta, and I've got 43 degrees, and then 27.3, which is just what I just found, and 30 degrees. Yeah, I'll use those two sides. So I'll say that the sine of the angle over 43 degrees is equal to the sine of 30 degrees over 27.3. Or rearranging this, sine theta equals 43 times sine 30 degrees over 27.3. So then we'll have that theta is equal to sine inverse 43 times the sine of 30 degrees over 27.3. And if we plug that into the calculator, we get, rounding it, about 52 degrees. Okay, let's do another example that's similar to that. Let's take one vector to be magnitude of 25. Again, that's the length of the vector. And another vector to be length 30. And let's say that the angle between the two vectors is 75 degrees. Okay, so we'll start by drawing a picture that represents what we have here. We've got a vector here. Let's call this 30. And let's call this vector here 25. And we'll say that this angle here is 75 degrees. The result is going to be what we find by drawing a parallelogram from the two given vectors. And so the result is going to be this vector here. This will be u plus v, right? This vector here is v, and this vector here is u, and that red that we have across the diagonal is the result. The direction that an object would move if we had two different forces acting upon it at the same time. I tell students, if you think about maybe a tennis ball sitting here, and I had a string going in one direction, and I had a string going in this direction, and I pulled both strings at the same time, the object would fly in the direction that you see the red vector. That's a way to sort of think about it. So let's start by finding the length of the vector. This is what we did. We did before we used the law of cosines in the problem before. So the length of u plus v is going to be the square root of the first side squared plus the second side squared minus 2 times the two sides multiplied together times the cosine of the included angle, which is, oh wait, time out for a second. No, this is wrong. We need to first back up for 1 second. If we know that this is 75 degrees, then this angle has to be 105 degrees, right? When you have a parallelogram, two angles that are adjacent to one another have to add up to 180. So because I'm using the law of cosines, I have two sides. I'm using this side over here, the 25 that's down below, to get that triangle diagonal across the middle. So in this case, I need to use 105 degrees because I've got the two sides and the angle that's in between them. Okay, plug that into a calculator to get the length of the vector. And I'm getting that it is approximately 43.7. Then the second part is to find the angle that's in between the vector and the resultant vector and vector u. So what we're looking at is we've got this triangle. I'll kind of draw a different version of it here. This is u plus v. This is the angle that we want here. This is 25. We know that this is 105. And we know that this is 30. We said that this is approximately 43.7. And we want to find theta. So we'll set this up as a law of cosines. We can say that the sine of theta over 30, the side that's across from it, is equal to the sine of 105 degrees over 43.7, or sine theta equals 30 sine 105 over 43.7. Theta is sine inverse, right, of this whole quantity. And I plug that into the calculator. And we get that theta is approximately 42 degrees. All right, let's go to an application problem. In this example, we have a wheelbarrow and it's being pushed with a particular force. So the person who's pushing the wheelbarrow is pushing it with a certain amount of energy. And then there's an angle that's created, and from the horizontal, in this case, it's from the ground, and then how far the wheelbarrow is being lifted up from the ground, and that looks like it's making a 38-degree angle. So they're wanting us to find two components, the horizontal component and the vertical component. What we mean by the horizontal component is how much force is needing to be pushed in this direction. And while it seems like it's 97 degrees, that's how much force he's exerting, but that's not the same as the amount of force that's happening on the wheelbarrow, because the wheelbarrow has a wheel. And so some of the force, it doesn't need as much force to push it because it starts to roll. So that would be the horizontal force. And that's competing with the pull of gravity, which is going to be the vertical component coming down this way into the ground. And so you've got these two things that are happening. You need to push it with enough force going forward that it compensates for the gravitational pull of the weight of whatever's in the wheelbarrow pulling it down. So we have this triangle that's created based on what's drawn here. Let's kind of draw a triangle for what we have. We know that the angle that's being created here is 38 degrees. We're trying to find A, which is going to be the horizontal component. And then we're also trying to find B, which is the vertical component. And we know that the total force is 97 pounds in this case. All right, so if I look and think about maybe just some trig identities that I know that the cosine of 38 degrees is going to be A over 97. Or another way of writing it is that A is equal to 97 times the cosine of 38 degrees. So A, or the horizontal component, plugging that into a calculator, gives me 76.44. Following that same logic for the vertical component, I can say that the sine of 38 degrees is equal to B over 97. Or B is equal to 97 times the sine of 38 degrees. And then plug that into a calculator, And we get that B is approximately 59.72. So what does that mean? That means that the amount of force being used to push the wheelbarrow forward is this 76 pounds. And the amount that is being pulled downward is 59 pounds. All right, let's look at a second example of an application. We have an airplane that flies 32 degrees for 210 kilometers. This is a navigation problem. And then it flies 280 degrees for 170 kilometers. How far is the plane from the starting point and in what direction? So what we're going to do is start by drawing a picture to show sort of the different components along the flight of the plane, so we can figure out maybe how far it is from its initial starting point. All right, so remember that when we talk about direction, we're going to take a hang on one second. Okay, so when we talk about direction and there is no north, south, east, west that are given, we think about moving from a northbound direction to start and then going clockwise. So this is kind of opposite of what we think about as far as trig is concerned. We think about a clockwise rather than counterclockwise. So bear with me while I draw a picture for this. So let's say that we're starting, oops, whoa. We're starting, let me make this bigger. Let's have our starting point be right here. And if this is sort of our northbound, what we're going to do is we're flying 32 degrees, so we're going to go clockwise. We're going to make a 32-degree angle this way. So this is 32 degrees here. And the distance that the plane has traveled is 210 kilometers. Okay. Then at this point, it then goes 280 degrees. So what I'm going to do is I'm going to draw a new sort of axis system here from this point. And 280 degrees is going to go all the way around here. That's 270, and then an additional 10 degrees here. So it's going to go like this, right? So let me get rid of that. This is 10 degrees right here in this little space, but that orange is going all the way around. That's going to be the 280 degrees. And then that distance the plane flies is 170. It's probably a little bit too long, right? 170 kilometers. Okay. And then what I'm trying to find is how far the plane is from its initial place that it took off. So I'm trying to find this distance here. Let's call it D. And then I'm also trying to find what this angle is. Let's call this theta, right? What direction it is from where it started, and then also the distance. So kind of redrawing this triangle over here. I've got, this is 210. This is 170. I'm trying to find this distance. And I know that this angle here, that's what I want to figure out. What is that angle? Well, let's draw a little triangle in the original that we had. In the original that we had, if I make this a right angle here, I had 32 degrees down at the bottom. I had, and so because this is a right angle, that means that this is 58 degrees. And so 58 plus 10, this angle in this triangle that I've drawn is going to be 68 degrees. So now that I've got that, I can use the law of cosines to find that distance d. So d is going to be the square root of, using the law of cosines, I take the two sides and square them, minus 2 times the two quantities multiplied together, and then multiplying by the cosine of the included angle. Plugging that into the calculator, we get that the distance is about 215 kilometers. The second part is to find that, that missing angle. And so once we're able to know this additional missing side, if we say that this is 215, then we can use the law of sines to find the angle that we're trying to find, which is there. So we'll write that as the sine of theta over 170 is equal to the sine of 68 degrees over 215, or sine theta equals 170 sine of 68 over 215. And then in calculator, we'll enter theta is equal to sine inverse this whole quantity. Right, so entering that into the calculator, we get that the angle is approximately 47 degrees. All right. But again, going back to the original, what we found is that this angle here is 47 degrees. But when we talk about direction, we're actually going from a northern direction and then going in a clockwise space. So we're actually talking about starting from the northern direction and going around to here, right? So what we really want is 360. Let's see. Let me draw another picture over here. We have let me erase some of this. Hang on. What I have is no. Hang on. I think I can copy that. And paste it. Ooh, I'm getting crafty now. There we go. Okay. So originally I had a 32-degree angle like this. But we just found in what we were doing that this angle was 47. So that means that this little sliver here is 15 degrees, right? Okay. So that helps us because when we talk about direction, we're actually going this way. We're going in a clockwise fashion. So the direction for this particular case from where we started, which was here, and ending up here is going to be 360 minus 15 degrees, or 345 degrees from the original starting point. So 345 degrees is the direction that that the plane ended up from its original starting point. Okay, I think I have one more application problem to show you. This is a common sort of physics problem that you might encounter, those of you that are taking or will eventually take physics. We have a shipping crate that has a certain weight and it's on a loading ramp, and the ramp has a 30-degree incline. So let's draw that to start. I'm going to draw this sort of over-exaggerated just so we can draw a lot of the components together. This is definitely not a 30-degree angle, but I just want to overemphasize so I have room to draw. So I've got this, I don't like how crooked that is. I've got this 30-degree incline. And there's a crate that's sitting on top of the incline like this. And for it to sit and not slide down the ramp, there's a certain amount of force that has to be coming into the ramp because we've got different forces of gravity working upon it. And so we want to figure out what the two different magnitudes are. One is going to be horizontal or perpendicular, and one is going to be parallel. Horizontal and vertical are sort of shifted because we've got this ramp that's sliding. So one of the forces is parallel. And let's draw a triangle sort of inside here. Let's see, we'll draw it like, this is my perpendicular force. Perpendicular to the plane or the incline, let's call that A. And then we've got a secondary force, which is going parallel to the plane. Let's call that force B. Okay, so I'm going to draw a triangle here like this. We're going to kind of consider that. And the two forces are going to be based on this orange triangle that I've drawn sort of in the center, but we don't know what any of the angles are. We know that this is a 90-degree angle, but we don't know what the other two angles are. So let's think for a minute about sort of, there's this idea that we had back in trigonometry that if we have two parallel lines that are cut by a transversal, it's just another line that cuts through the two lines that's not perpendicular to either of them or parallel to them, we have these relationships between the angles that make them equal. And one of them is what's called alternate interior. Alternate is on opposite sides of the transversal, the line that's cutting through them, so one above, one below. And then interior means that they're both on the inside of the parallel lines. So in this case, alternate interior, alternate interior would be, one would be here and one would be here. Those are going to have the same measurements as one another, both inside the parallel lines, one above the transversal, one below the transversal. We do have parallel lines here, even though it's sort of hard to see them. We have got, I'll use the highlighter, this line here, and even though this line here are parallel to one another. I know that this angle over here is 60 degrees because this is a right angle, right? And I've got this large blue triangle that's happening. And if I think of this line, let's make it green. If I use this as the transversal, then this is on the inside of the parallel lines. And so that means that this angle here, I'll make it green as well. This angle right here is also going to be 60 degrees. Those are alternate interior angles. I know it's super small and hard to see, but those are alternate interior angles on the inside of parallel lines on opposite sides of the transversal. So this is the transversal. This is a right angle right here. So that means that this angle here is 30 degrees. It's sort of this really weird phenomenon, and when you do a lot of these problems, you just start to understand that the angle that I just noted is the same as the angle of the incline. And it's sort of this relationship among all the different components that are happening. But when you go into physics, you'll have problems like this frequently. All right, so we want to figure out what the components A and B are, the two forces that are acting upon the crate that's sitting on the plane. We know that the cosine of 30 degrees is the opposite side, which is no, adjacent side, 450. 450. Oh yeah, that's the force that's being acted. I didn't write that. This is the force because it's coming straight into the ground. This is 450. The force or the weight of the crate. So the cosine is the adjacent side, 450 over the adjacent side, A, over the hypotenuse, 450. There we go. Adjacent A over the hypotenuse, 450. So 450 times cosine of 30 degrees is equal to A, or A is approximately 389 point, running out of room here, 389.7 kilograms. I don't know why I wrote degrees here. This should be kilograms, right? All right, following that same logic, we can find the other component, which is going to be parallel to the ramp. So the cosine, or no, the sine of 30 degrees is going to be the adjacent side, B, over the hypotenuse, 450. So 450 times the cosine of 30 degrees is equal to B. And so B is approximately 225 kilograms. Okay, those are some of the sample problems from sections 8.5. I will make another video for section 8.6. Have a great evening.